All right, guys, so I would like to talk about 11.2 for a little bit, which is roughly inverse function.
Oh, we were just talking about that.
Yeah, we were just talking about this. So we had this concept of a function before, right? So our concept of a function before was something like this, right? We had a blob, and we had a rule, and that made something in a different blob, right? So these were the like inputs. These were the outputs, right? Sometimes we thought x's and y's, right? What did we call this input place? So the set of all the inputs, we had a name for that.
Domain.
That was the domain of the function. And then the outputs, that was the
Range.
range. Very nice, guys. Okay, so today is going to be a little bit about when is it possible for me to ask about this arrow? Right? So f is something that does, right? This takes numbers and turns them into other numbers. Or I might think about this takes how many times the basketball is bounced and turns it into the height, right? That was one we just did. So I've got some kind of input, some kind of output. And I'm wondering, is there a way for me to flip that over? Does that make sense? Like, can I take the output and find out what input gave me that?
Yeah.
Yeah, this is really solving, right?
Okay.
So sometimes, not always, we'll be able to make a function that does this. Cool? So what I really want to ask is, when is an undoing a function? Does that make sense? So oftentimes I can kind of draw this arrow, and usually I can even think about what it means. Right? But sometimes it's not a function. So I need to remind you of a little part of the definition of a function to get to this question. So the definition of a function was what?
The one equal.
So a function is a rule, right? Associating inputs to outputs. We're good with that part, I think.
Yeah.
And then what's the little but?
Domain.
Each input will have only one output.
Yeah, that's the thing. With each input having only one output. You guys see that? It's the only one output. That's the hard bit here. Cool? So let me give this by example, maybe. If I think about the rule that says f of x is 2x, right? Is there an undoing for this? So if I think about kind of x's and y's, what's f's rule? What does it do to x's?
It switches.
When I put an x in here, what do I do to it?
Divide it.
You're jumping ahead. When I put an x in here, this multiplies by 2, right? I see that? So this rule, another name for the rule f is multiply by 2. Yeah, what's up?
Okay, so I can't remember. I know that, like what she said, where it can only have one output, but isn't it the same if it's like two separate ones that both go into one input? That's also not a function?
No, that's a function still.
That is?
Yeah, so I'm allowed to have, right? each input needs to have only one output, but I'm allowed to have an output that has a couple inputs that go there.
Okay.
But that's going to be the problem with undoings.
Okay.
You guys see that? Maybe not. Let's get there. So if I have an x and I multiply it by 2, is there a way for me to undo that and get back to the x I started with for sure?
Divide.
There has to be.
Yeah, I should divide, right?
So is this whole thing basically just division?
Not quite.
Wait, it could be multiplication and addition.
Yeah, we could do addition and subtraction instead.
Or multiply
Yeah.
by half.
Yeah, we could think about this as multiply by a half, right? Divide by 2 and multiply by a half are the same thing. So this is one where I'll be able to think about the inverse function, right? Without really having done anything. I didn't really check anything. I just know that multiplying by 2 and dividing by 2 undo each other, right? And that works for all the x's. So I could say this. I could say f inverse of x is 1/2 x.
Yep.
Okay? So this little bit here, this guy, this is really just me saying f's inverse you guys see that?
Wait, you're saying that x is the f's inverse?
No, I'm saying the rule that inverts f
Oh.
is 1/2 x. Okay? Multiply by 2. If I want to undo multiply by 2, I should divide by 2, right?
Yes.
Okay, so here's a rule that says take an input, divide it by 2. You guys see that? Right, multiply by a half, divide by 2 are the same thing. So I just reasoned through the idea that the undoing of f, which is really all this symbol means. So this means f's undoing as a function of x, right, is take the x and multiply by a half. So I doubled it and then I undouble it to get back, right? You guys all see that? Okay, the problem, the question that I'm trying to answer is when is undoing a function? Well, this was a nice example. I was able to figure this out. What if I asked maybe a different one? I'm going to leave this a little bit. This is a not example. Okay? If I talk about, say, g of x is x squared, right? So I've got kind of my blob. My rule is square things. What's this space over here? What's the domain for squaring?
Where's roots?
What numbers can I square?
Oh, 2, 4, 6.
All of them, right?
Oh, yeah.
So the domain on this guy is all real numbers. What's the range of the squaring function?
All real numbers. There's no.
It's got to be positive, right? If I square a number, it's going to be positive, right?
Right.
So I get the interval from 0 to infinity out, right? You guys see that? How about a picture? What's x squared look like as a picture? Like a parabola, right?
Oh, yeah, okay.
So here's g. That's x squared, right? Okay, so I'm asking about undoing this, right? So what would I undo this with?
Square root.
Yeah, square root seems like a natural idea. I'll write this in red because it doesn't quite work. Okay, so it seems like the square root should go this way, right? You guys all with that? But what's the problem with the square root? Oh, yeah. Okay, so if I'm trying to solve, right, if I'm asking, okay, here's a height, right, maybe for example 4. What goes to 4? What are the x's that go to 4? 2 and
Negative 2.
-2,
Okay.
right? So here's an x that goes to 4, right? Here's another x that goes to 4. So if I'm going to undo this rule, right? Really, I'm kind of thinking, okay, -2 and 2 live over here in the domain. When I square them, they go to the same place over here in the range. They both go to 4. Right? Now I'm asking if I'm going to undo this thing, right? If I'm going to reverse the arrows, my undoing should have this, right? Should take 4 to both of these guys.
It's not a function.
This thing's not a function. You guys see that? It takes one input, 4, and takes it 2 places. That's really, oh, this thing doesn't do that though, right? The square root function just takes 4 to +2. You guys see that? It only half undoes. Okay, see that? I had to pick one. So this thing's not an undoing function. It's a half undoing function. It's a one-sided inverse, but forget it. We don't need that. All I need for you to know is that it's not an inverse function, right? Remember we had all that trouble trying to sort out what the square root of x squared was and this x squared, sorry, let me write instead of asking. Remember these guys? We had the square root of x squared, we had the square root of x squared, right? And we wondered, were all these things the same? They're not the same, remember? That's because this thing, square root of x, doesn't undo x squared. The reason it doesn't undo it is that this guy took 2 things to the same spot. You guys all see that? So we should have a word for that. You guys cool with us?
Not inverse function.
Yeah, it's a not invertible function. What's up?
Okay, so this might be a stupid question, but, so I know that like divide by 2 and multiply by half are the same thing. Is it the same with like if you were to do divide by 5 and then like multiply by a fifth? That's still the same thing?
Yep, this is still the same thing. And those are both the inverse function of multiply by 5.
So basically, we're just doing the reciprocal.
For multiplication, it's the reciprocal. For addition and subtraction, things are a bit different. So
I thought multiplication and division were the inverse of each other.
they are. And addition's the inverse of subtraction, right? So those things get paired. Well, we'll get some more examples of this. Right now I just need to get this one definition, and then we'll play with it for a bit. So here's the definition we need. So a function is 1-to-1 well, what do I mean 1-to-1? Really, I mean one input to one output, right? So if each output has only one associated input. You guys see that? So if I wanted to ask about x squared, is x squared 1-to-1?
No.
No, because it takes 2 and -2 to 4, right? You guys see this? Yeah.
So it will not work if it's even, but it will work if it's odd.
The powers?
Yeah.
Not quite. For x, so for the monomials, yes. For polynomials, that becomes more problematic.
If it's a parabola, then it's gonna be non.
Yeah, if I'm looking at a parabola or a similar shaped thing, then it's pretty clearly not one-to-one, right?
So a parabola or the V.
Yeah, or the v isn't one-to-one, the absolute value function isn't one-to-one. You guys want that, there's a test for this that you guys are already doing, it seems like. So the test for this is this thing called the horizontal line test.
I've heard of that.
Okay, so what's the horizontal line test say? What's the vertical line test say? You guys remember that one?
Yeah.
If you've got some squiggle, right, and you want to know if it's the graph of a function, you put vertical lines through it and ask, does it intersect more than once, right? This thing's the same thing for the inverse function. So I'm looking at a graph, and I'm wondering if that graph makes an invertible thing. I run a horizontal line through it and ask if it intersects more than once. So the horizontal line test reads, the graph of a function this is really not quite right. Let me rephrase. So, a function is invertible, which is really the same thing as one-to-one. If its graph intersects any horizontal line at most once. Oops.
Wait, isn't it?
You guys want to play this game for a minute?
This, I'm confused. Zero slope. The line is horizontal.
Yeah.
Does that have something to do with it?
It's just telling you what the horizontal lines look like. Horizontal lines look like y is a number, right? Which means that they have zero slope. So let's practice a couple. So are these functions invertible? Right? So here's one. This is a cubic. Yeah, there's a funky W, there's a cubic. What's this one look a bit like? Not the square root. But yeah, that looks like x cubed. This is a cubic that's not a monomial.
And that intercepts twice, so that would not.
Okay, so let's look at our horizontal lines. So where's a horizontal line that hits this one more than once?
3 times.
Oh yeah, the x-axis actually does. So this one's not a function, or not an invertible function, right? It's still a function. Vertical lines only hit once, but the horizontal lines cause problems. Okay, see that? So this is not invertible. How about this guy?
Yes.
Yeah, that seems like yes. How about this dude?
No.
No? Oh, the x-axis is still a problem. How about this guy?
Yes.
Yep. Very cool. So, notice, this is a line, right? Are lines going to be invertible?
No.
Well, yeah.
Are all lines invertible? Can you draw a line that fails the horizontal line test?
No.
Yeah, horizontal lines fail the horizontal line test. Right, so as long as the slope's not 0, you can invert a line. Right? If the slope is 0, you can't invert. Okay, see that?
So if the slope is 0, then you can't invert.
Yeah. Slope of a line is 0, it can't be inverted. All the other lines can be. This is maybe x cubed, right? If x cubed is invertible, what is it invertible by? In other words, do I know the inverse of the cubing function?
Divide.
Cube root. We've been using those to undo each other like mad already, right? We already know some inverse functions. Every time we're solving, right, when we make those arrows, those are a try and an inverse function. Sometimes they're a good inverse function and they just work. Other times, like with the square root or the fourth root, I have to worry, right? So that's because those things aren't inverse functions. You guys see that? Okay. So this is what I want you to take from inverse functions for right now. We're going to try to graph some more later, and we're going to actually get some practice getting a few in a bit. But I need to give you a quiz. So this is 11.2 for now.